We're going to look at assignment 48, and we're going to look at problem C, which is one of the problems from the back of the chapter. Okay. All right, so this has a lot of parts to it. So it says a 200-gram mass. So what I would always do is I would convert things to my basic unit. So 200 grams is going to be 0.2 kilograms. Is attached to a horizontal spring, and it oscillates at a frequency. So the frequency is 2 hertz. At t is equal to 0 seconds, the mass is at x is equal to 5 centimeters, and v sub x is equal to negative 30 centimeters per second. So the first thing I'm going to do is, again, I'm going to do all my conversions before I start reading stuff. So this I'm going to convert to meters, so that's going to be 0.05 meters, and then I'm going to convert this to meters per second, which would be negative 0.3 meters per second. So this way I don't have to do any conversions as I'm reading everything else. So part A says find the period. So the period is t. So period is 1 over the frequency. So because they gave me the frequency, this is simple. So it's 1 over 2. And remember, a hertz is 1 over a second. So 1 divided by 2 is 0.5. And then with the units, even though I know periods measured in seconds, remember, if I carry my units through and cancel them, 1 over a second is a second. So I know that's correct. All right, part B says find the angular frequency, which is omega. So t is equal to 2 pi over omega. So what I'm going to do is I'm going to rearrange the equation to solve for the unknown in terms of the known. So omega is equal to 2 pi over the period. So this is going to be 2 pi over 0.5 seconds. So this will be 4 pi radians per second. Part C says find the amplitude. Now remember, the amplitude is the maximum displacement, but this is not the maximum displacement. We just want to find this amplitude, okay? So the amplitude here, we're going to look at the basic equation. Now we know the basic equation is x is equal to a cosine omega t plus the phase constant. Now, one of the things is we want to find the amplitude. So the amplitude is A. Now, maybe there's more than one way to do this problem. Again, when I'm doing a problem, sometimes there can be 2 or 3 ways to do it. You should always stick with your the first way that comes into your head. Okay? So when I do all this, when I substitute in my values here, 0.05 A cosine 4 pi, but remember t is 0 plus the phase constant. So my issue here is I have an equation, but I have 2 unknowns. I want to find the amplitude, but I don't know the phase constant. So what do I do? Well, one of the things I know is if I'm going to look back at my given. I'm going to say, well, what else do I know? So when I look back out up here and I'm like, what else do I know? Well, I see that I have the velocity. So what I can do is I can take the derivative of this. So the derivative of this is v is equal to negative omega a sine omega t plus the phase constant. And I can now substitute in negative 30.3 meters per second minus 4 pi radians, but time is 0. Oh, wait. 4 pi A, let me already put the 0 in, and then sine of that. Okay? So here I see that I have, again, 2 unknowns. Okay? So if I have 2 equations and 2 unknowns, you can either substitute one in the other, or a lot of times, now it's just math. Okay? So what I would do is I would just say, you know what, I'm going to rearrange both of these for one of the unknowns. My two unknowns are A and the phase constant. So I'm going to substitute them both for A, and then I'll set one equation equal to another. So 0.05, A cosine, and then over here I'm going to have negative 0.3, negative 4 pi sine, I forgot the A, sorry. So now I'm going to rearrange them both for A. So on the left side I have it, even this is just math. Okay, this isn't the physics. So over here I'm going to have 0.05 times cosine of this is equal to A, and then on this side I'm going to have negative 0.3 net over 4 pi sine of the is equal to A. So now A is equal to A. So I'll have the two equal to each other. So it's 0.05 cosine is equal to 0.3 over negative 4 pi sine of this. So then I'll cross multiply. When I cross multiply, I get 0.05 times minus 4 pi sine is equal to negative 0.3 cosine. Now, if I rearrange this, what are you going to see? You're going to have sine over cosine. Sine over cosine is tangent, right? So now we have tan is equal to 0.3 over 4 pi times 0.05. So when I do all that on my calculator and inverse tan, I get that this is equal to 0.445, and make sure your calculator is in radians. Okay. For part, so that was literally the hardest part. Oh, so we still had to find the amplitude. So the amplitude, sorry about that, the amplitude, and you know what, there's probably an easier way to do it. So the amplitude, I'm just going to go back to this and substitute it in here, or I could use the other one for amplitude. So the amplitude is 0.05 over cosine of this. So it's 0.05 over the cosine of 0.445 radians. And that comes out to be 0.0554 meters. Now, the weird part is, and like I said, there's probably an easier way. Now it says, what is the phase constant? So there was probably an easier way. And sometimes, I don't think of the easiest way, that you would probably find the amplitude first and then go back and find the phase constant. You know what I'm saying? But that didn't happen this morning. So we already know that the phase constant was 0.0445 radians, which we did up there. Part E said find the maximum speed. So the maximum speed, Vmax, is equal to 2 pi a over the period. So that's going to be equal to 2 pi times 0.554 over 0.5. So that came out to be 0.696 meters per second. Part E, or was that was E. Part F said find the maximum acceleration. So the maximum acceleration, remember, that's now the second derivative. So A is equal to negative omega squared cosine omega t plus the phase constant. Now, we want to find, so for that instantaneous angle, which is matching a particular speed, so the maximum acceleration occurs at the maximum amplitude where the speed is what? 0. So this occurs, it's either going to occur at 0 degrees or 0 radians, or like 180 degrees or pi radians. So basically you can use either one, because I think you just want to find the magnitude, or it says the maximum acceleration. So if you want to find the magnitude, it's probably easier to use the pi radians or 180 degrees, because this way you get rid of the negative sign. So A is equal to negative omega squared A cosine of this. So then when I substitute in, it's going to be negative 4 pi squared 0.0554 cosine of pi radians, because that's 180 degrees. And when we do all that on the calculator, it comes out to be 8.75 meters per second squared. Part G, ooh, we're running out of space. It says find the total energy. So like I said before, when you have a horizontal mass oscillating in simple harmonic motion, when you think about it in terms of conservation of energy, at the maximum displacement, the potential energy is going to be a maximum, and the kinetic energy is a minimum. At the equilibrium position, that's where the potential energy is 0, and the kinetic energy is going to be a maximum. So we know the total energy is a sum of K plus U. So I'm going to do the equilibrium position where the potential energy is 0, so it's just going to be kinetic, so it's going to be 1/2 m Vmax squared. And that's because we found the Vmax in the last problem. So usually on an AP test, whatever answer you found in the previous is going to be the easiest way to do the next part. So we're going to use our answer in the last part, so it's going to be 1/2 0.2 times 0.696 meters per second squared, and that comes out to be 0.0485 joules. And then the last part, part H, says find the position at t is equal to 0.4 seconds now. So for H, again, we have x is equal to a cosine omega t plus the phase constant. So now I'm just going to substitute all the values that I just found. So it's going to be 0.0554 times cosine. So all of this, I'm going to have to do a big parenthesis. So it's going to be 4 pi, and then they told us t now is not 0, it's 0.4 plus 0.445. So remember, you're going to have to add these first before you press cosine, okay, and then multiply that. So be careful with your order of operations. And then this is equal to 0.374 meters. So this one had a lot of steps. What you notice was as you go from one to another, you know, some of the answers we found before you used. And yeah, there might be another way probably to do this a little easier instead of using systems of equations. But again, sometimes when you're doing a problem, you go with your first instinct in how to solve it. And that's it.